So go ahead.
Perfect. Hi, everyone. Quick introductions. My name is Max Karambelas. I'm the founder and CEO of CloudGo. I have on the call Nick. He's the CTO, founder of CloudGo as well. I'm going to start off with just a presentation today. Nick's going to do a demo afterwards, and then we'll have plenty of time for questions or whatever else. But yeah, thanks to Bishwas. We've been, part of the DevOps World community for almost a year now. It's been quite a while. We're on their landing page. They're on our landing page. And so it's definitely great to be here for the event. And yeah, we're looking forward to presenting for everyone today. So without further ado, I'll just kick it off if that's okay, Bishwas.
Yeah.
Share my screen real quick. Everyone good? See my screen? All right, cool. So the whole concept of our talk is that the real importance of using AI and just cloud and cloud engineering in general is not a bigger model, it's context. And I'll start off by saying that the uncomfortable thing about using AI for cloud engineering is that the answer is never almost obviously bad. And if you ask a frontier model to design a migration, modernize an application, or review a cloud environment, it's going to produce something that looks credible. And the architecture is going to sound reasonable, the phases are going to look organized, and the risks are going to look familiar. It's going to feel like something that you've done before. And that's exactly what really makes it dangerous, is that the primary failure mode is not that the model gives you nonsense. It's that the model is going to give you a professionally written answer that's going to be built on an incomplete or incorrect understanding of the environment. And we have spent a lot of time building AI-assisted cloud assessment and migration workflows. And the biggest lessons, that we have learned is that it's not really about model selection. It's about context engineering. And today I want to explain why better models alone do not solve this reliability problem, why retrieval is much harder than it first appears, and what cloud teams can do to make AI useful without giving up engineering control. So let's start with the familiar experiment. Take a description of an application and ask a strong model to plan a migration. It's going to compare things like lift and shift, replatforming, refactoring. It's going to explain the trade-offs. It's going to propose phases. It'll identify risks such as downtime. It may even produce an RACI chart, a timeline, a target architecture. In other words, it's going to produce the form of good architecture that works extremely well. And for consultants, this is especially compelling because the output's going to look like something you could put in front of a customer after a little bit of editing. And for internal engineering teams, it feels like a shortcut through several days of planning. But look at what we are actually evaluating. We are evaluating whether the answer is structured, whether the document is complete, whether the trade-offs sound reasonable, whether the model remember the right categories. What we aren't evaluating on is whether that premises is true. Did it identify the right application? Did it see all the dependencies? Did it understand which environment is in production? Did it imply the right internal standards? And did it know that the technically cleanest option was already attempted 2 years ago and abandoned for an operational reason? A plan can be internally coherent and externally wrong. And that distinction is going to matter a lot more as these systems become more fluent, because fluency makes weak premises harder to notice. This is the central argument of this talk. It's that capability scales the fluency of the guess, but it really doesn't scale what's the accuracy of the premise. And a better model may reason more carefully over the information it has and may identify more trade-offs. It may generate cleaner Terraform. It may produce a more nuanced migration sequence. But it still doesn't know that a cron job writes directly to a storage bucket unless you tell it. And it does not know that a database named prod db2 is actually a deployment instance. It doesn't know that your team evaluated EKS in 2023. It does not know that there's a security exception that exists in your ticket. It does not know that your runbook may be outdated. The model is not failing to reason in these cases. It is reasoning correctly over an incorrect representation of reality. And those are different problems. When we treat them as one problem, our instinct is to improve the model, extend the prompt, or add another agent. Often, none of those actions are going to actually improve the premise in this case. They simply produce the same plan more persuasively. Now, everyone here knows that an AI system needs context. That is not a new insight. The interesting problem is that most organizations already have the context, but they cannot simply just hand it off to the model. It's going to come distributed across APIs, Terraform states, records, diagrams, monitoring systems, internal docs, cost data. Some of it could be stale, some of it might contradict other sources, some of it might be sensitive, some of it's only visible from a specific account or credential, and some of it is technically available, but maybe has no useful semantic description. And some of the most important context also has just never been written down. It's all internal knowledge. And so the challenge isn't just connecting an LLM to more data, it is determining what the data means, whether it's complete and which sources should be trusted, what the system must do when the evidence is missing. And that is an engineering problem, not a prompt writing problem. So here's the 6 ways that your estate's going to lie to you. Cloud environments do not present themselves as a clean, unified system, as I'm sure a lot of people on this call know. They present multiple imperfect views of a system. The first problem is competing sources of truth. The console says one thing, the Terraform state says another, the running environment says something else. Maybe somebody made an emergency console change and never reconciled the code. Maybe the state file references a resource that was manually removed. Maybe the deployment pipeline is managing only part of the estate. An AI system needs an explicit rule for which source wins for each type of fact. And otherwise, it's going to combine contradictory evidence into one confident narrative. The second problem is names and tags. Names look like semantics, but they are often historic residue. A resource, again, I'll just use prod db2, maybe deployment, and a tag may have been copied from a template. Ownership may point to a team that was reorganized 6 months ago. If the tag coverage is incomplete, the model's not really going to know that the missing tags are missing. It simply builds its understanding from the tag subset. The third problem is a sensitive state. Terraform state, configuration files, and tickets may contain exactly the relationships the model needs, but they also need certain secrets, customer data, internal host names, or other restricted info. You cannot always put the raw resource into a general purpose AI workflow, and naively stripping the sensitive fields can also remove the evidence needed to understand the architecture. Then we have undiscoverable dependencies. Cloud APIs can reveal that 2 networks are peered. They may not reveal that an overnight reconciliation job will fail if, like let's say a Redis endpoint changes. The dependency may exist only in a script, a ticking comment, or again, someone's memory. There's also read-only blindness. We often say an agent has read access to the environment, but read access through a credentials, an account, a subscription, a region, a cluster. Whatever the credential cannot see may be interpreted as something that does not exist. Finally, cloud context is point in time. An inventory can be accurate on Monday and incomplete by Thursday. A planning process may take 2 weeks, during which the estate continues changing underneath it. Every engineer here has encountered some version of these problems. The issue is not that the environment contains no context. The issue is that the environment does not provide one trustworthy, complete, temporally available just representation of itself, and that is where the model struggles. This is the idea I would, I guess, most like you to remember from this talk, is that a model cannot distinguish really between this does not exist and you did not show me this, or at the very least, it definitely cannot distinguish between that consistently. In distributed systems, we understand this distinction intuitively. A timeout is not the same thing as a negative response always. No metric is not proof that no event occurred. And an empty query result may mean that there is no data, or it could mean the query lacked permission, it targeted the wrong account, whatever the issue might have been. But AI infrastructure workflows frequently collapse these states together. And suppose the model does not retrieve, let's say, a NAT gateway cost data. I will not necessarily stop and say, I could not verify your network egress costs. It's just going to simply produce a cost model without them. Suppose it might not see your second AWS account. It may describe the visible account as the entire estate. Or suppose a dependency is missing from the documents. It may sequence the migration as though that dependency just does not exist. The confidence and the tone of the answer are often identical whether the system examined complete evidence or only a partial slice of it. And every retrieval gap, therefore, becomes like a silent assertion almost. And that is why citation alone is not enough. A system can cite every piece of evidence it retrieved and still fail because it did not retrieve the evidence that would have changed the conclusion. A trustworthy system must expose both what it found and what it expected to find, but could not verify. The absent has to become a first-class output. This leads to a harder point about just retrieval in general. The entire cloud estate does not fit into one useful reasoning context. I can't plug a 10,000, 20,000 resource AWS enterprise instance all into cloud at once. And so even if a model technically supports a very large context window, just dumping everything into it is not going to create understanding. It's going to create noise, costs, conflicting evidence, and difficulty determining which facts influence the answer. Something has to choose the relevant slice. This could be a vector search, a graph traversal, a SQL query, a tool using agent, a set of hard-coded rules, or some combination of these systems. But whatever selects the slice has already made a large part of that decision. If a migration question, compute inventory, or retrieves compute inventory, but let's say not DNS, for instance, or it doesn't have identity, observability, batch dependencies, then the resulting plan has already been constrained before the reasoning of the LLM even begins. Retrieval is not neutral plumbing. It is an opinionated policy about what matters. And there is a chicken and an egg problem here. To retrieve the right evidence, you need to understand the decision. But to understand the decision fully, you often need to examine the evidence. Bishwas.
Yes, I have a quick question on the retrieval mechanism. So you are referring to have a context for the historical thing, right? To have all the data on how it was there. What if the process ends abruptly in the middle? How is this gonna help me? Because I ideally, when now the process stops, it needs to reread all the previous things it has done, and then it works. So what the added advantage, or how it differs now versus earlier without context?
Sorry, just repeating the question so I understand. You're asking the difference between using context versus not using the context? I just want to
Yeah,
make sure I'm
yeah,
understanding.
yeah.
Okay. So yeah, I'd say the big difference between using the context and not using the context is kind of what let me go back, went through earlier. It's things like really understanding gaps in the infrastructure. It's really hard to properly insert the right context in the conversation and make sure you have it all, because an LM is not going to be able to catch things like this does not exist versus you did not show me this. So if you forgot to say something and you plan out a 6-month, 5-phase, migration plan for your AWS GCP migration, for instance, you can't always trust that the LLM is going to catch you if you didn't get the right context. And it's not really feasible for a person to know all of the possible context to feed into the LLM to work with it. Because as I mentioned earlier, there is like that read-only blindness of, some things are internal just in my head that I know just from working the system. We've tried things in the past that will influence how we do a migration today. There's telemetry we need to take into account. There's business best practice for our specific organization. That's where this kind of context really comes in, and where it's important is how do you address those gaps very, comprehensively before you even start that kind of reasoning process. So that's kind of the whole point of it, is just how do you shore up those gaps for yourself.
Thanks. Answers.
No problem. So just where I left off, to retrieve the right evidence, I mentioned that there's a chicken and egg problem. To retrieve the right evidence, you need to understand the decision. To understand the decision fully, you need to examine the evidence. So you do not know that Redis matters, let's say, until you see the application dependency. And you're not going to retrieve the dependency because the original question might not have mentioned Redis, for instance. And this is why I am skeptical when someone says we pass only the relevant context to the model, as though relevance is like a solved processing step. That statement describes the goal. It does not explain the actual method to get there. RAG can make information addressable, but it's not going to automatically make retrieval complete. A knowledge graph can represent relationships. It does not automatically prove that all meaningful relationships were captured. And an AI agent can call tools, but it does not automatically know which tools it failed to call. And the honest answer is that relevance is iterative, and that the system needs to retrieve, reason, and identify uncertainty to preserve a visible record of what it could not establish. A useful mental model, is to separate reasoning from grounding. Models genuinely are good at reasoning tasks such as comparing options, exploring trade-offs, drafting plans. Those capabilities are valuable, and grounding has come from your side of the system. Grounding includes the current state of the estate, dependency relationships, internal policies, operating procedures, and you can improve the reasoning model without improving that grounding layer. You could also improve grounding without changing the model. And this distinction becomes especially important with agents. The immediate objection usually is agents can now retrieve their own context. They have MCP servers, tool calls, API shells, read access. Doesn't that collapse this distinction? It moves the distinction. It does not eliminate it in our view. And an agent with tool access is an operator with tools. It is not omniscient. It still has to decide which tool to call. It still has to interpret the schema. It still has to know whether the credential scope is complete. It still has to recognize the two systems disagree. It still has to determine, whether an empty result means nothing exists or I looked in the wrong place. And every additional tool expands both the capability and the surface area for that silent omission. So tool access really is not the same as contextual completeness. And the goal for you guys should not be to give an agent unrestricted access and just hope it discovers everything. The goal should be to make the estate legible, define whatever the available evidence is, establish those authority rules, and make retrieval failures just observable. And then the model can do what it is good at, reason over a representation that has explicit boundaries. This is why we believe the human in the loop is not the only sufficient safety strategy. A person reading a long generated AI plan is not automatically a control. The document may be polished, the reviewer may be busy, the incorrect premise may be buried 3 sections earlier than the recommendation it affects. A real review gate needs falsified checks. So first, assumptions declared. What did the system assume it could not verify, for a fact? Not just a generic disclaimer that information may be incomplete. List the specific assumptions that affect that decision. Second, evidence cited. Which resource, state entry, API response document, or policy supports the conclusion? Third, blast radius. What else touches the resource being changed, and how was that relationship established? Rollback criteria, not simply just have a rollback plan, but what observable condition triggers rollback and who has the authority to initiate it. In case of a named owner, 5 here, it's not just the platform team. A specific person needs to be responsible for reviewing or executing the decision. Human review works when the human is reviewing structured claims against structured evidence, and it is much weaker than the human is merely being asked whether a professionally written paragraph feels reasonable. I would encourage you to use these 5 checks, even if your current AI workflow is just an engineer using ChatGPT manually. And I'll put the checklist in the chat after the session. I'm sure we'll send something out. So, what can a team actually do with this, let's say on Monday, for instance? First, name the decision precisely. Help me migrate this application. It's not a useful decision boundary. A better question is, can this application move to EKS without an outage longer than 5 minutes? And which dependency is most likely to prevent that? This question identifies a target platform, a surface level constraint, and the type of failure we are trying to uncover. Second, I would say enumerate the facts required to answer the question before writing the prompt. For this example, we might need application topology, request flow, session handling, storage dependencies, database behavior, current deployment method. The act of listing the required facts is valuable even before the AI enters the process. It exposes what the organization does not know. And third, decide which source wins for each type of data. For inventory runtime, perhaps the cloud API wins. For intended configuration, perhaps the version control infrastructure wins. For costs, billing exports win. The authority rule may differ by data type. The important thing is that it is explicit and reusable. Fourth, make these gaps loud. Do not let missing information disappear into the prompt. represent it directly. Database replication method, unverified, rollback owner, not assigned, peak transaction volume, the data was older than 90 days. Those gaps should appear next to the recommendation, not in a generic disclaimer at the end. Fifth, gate the output using the checklist we just covered: assumption, evidence, blast radius, rollback criteria, owner. What are we really creating is a decision contract. The system states the question is answering, the evidence is used, the evidence it lacked, the assumptions it made, and the conditions under which its recommendation should not be trusted. This is the difference between using AI to generate content and using AI inside an engineering control system. None of this requires buying a new platform. You could start with a spreadsheet, a repository template, a structured prompt, or an internal review process. It's not going to require deciding what trustworthy reasoning means to your organization. And that is the work most teams are currently trying to skip. At CloudGo, for instance, we have been applying this approach to cloud assessment and migration planning workflows. I want to be precise about the numbers because infrastructure AI has enough vague benchmark claims already. We group the numbers by how they were produced. The first group is directly measured in customer pilots and internal runs. And you can see we have current state assessment completed 68%, 60, 80% faster with a better context layer, for instance, when inventory collection, normalization, and evidence retrieval are automated. This does not mean a migration is finished in 4 hours. It means the team has a structured artifact it could begin reviewing, correcting, and using for a customer or internal planning discussion. We also see that here that context and token usage is reduced by roughly 50 to 70% because of this layer. And by structuring information, as I've talked about, and retrieving targeted evidence instead of repeatedly passing large documents or inventories into the model. The next numbers are Rubik's score. We evaluate things like 85 to 90% report and artifact readiness. And basically what we're getting there is that the resulting report contains required sections, evidence, dependencies, and on that basis, we see this percent increase or greater artifact readiness just before that final human review. Final number that we're getting, and all this derived from the context layer, is that 30 to 50% less overall planning effort is modeled from the measured reductions in assessment, drafting, and revision time. It's modeled, I'm saying that word intentionally. The result is going to vary based on the quality of the starting data, the complexity environment, and how much institutional knowledge has never been captured. The larger point is not that AI eliminates cloud planning, it is that structuring context changes where engineers spend their time. Less time copying inventory, reconciling documents, and formatting reports, more time challenging assumptions, resolving gaps, and making actual engineering decisions. I'm happy to be challenged on any of these measurements during the questions. And so I will kind of leave you off today with just saying that model capability is probably not the primary bottleneck in your AI cloud workflow if you are, not getting the best use out of, let's say, Fable or Sol today. The bottleneck is that your state is not legible. Your infrastructure data is most likely incomplete, contradictory, sensitive, distributed, and also just constantly changing. And the model is not going to tell you it could not see unless you design a system to surface that explicitly. So do not begin by asking how to make the model more confident. Begin by asking things like, what decision are we making? What evidence does it require? What sources do we trust? And how will the system report what it failed to verify? Make those gaps loud. And then once that process is complete, then you let the model reason. And with that, I'm gonna, finish my presentation. I'm gonna hand it off to Nick, who is going to show you what this looks like, in a live migration planning workflow. Vishwas, I don't know if we want to separate these two sections of questions or just do questions all at the end. I'll kind of leave that up to you.
I think let's open for a few minutes if anyone has a question. If not, then we can start.
Now we could go for like 5 minutes, 3 minutes, and if there's anyone that has questions.
Oh, there is no question in the chat?
No, there's no question in the chat, but the audience can also ask questions now. We could just give like 3 minutes. If there's anyone who has a question to ask, you could ask then before we can proceed.
Yeah.
Anyone?
I see one from George
Okay.
in the
Do I
chat.
read it?
Yeah.
So it said, Max, and the question is, are you using one model under the hood or many? How much do you find that switching models affect your performance? Models affect your performance, and even with all the context you have from George.
So yeah, we do use a mixture of models, and we really, I guess, lean towards the efficiency approach, where the majority of the work under the hood, because decisioning about these queries is really taking place in the retrieval of our context layer, we are using very low cost models for a lot of the reasoning and creation steps. And then only when it comes to creating something like a stylized one pager or a chart or something that requires a deeper reasoning model, that's when we're going to kick in something like, the newest Soul model or a Fable or something. But for the majority of CloudGo processes, we're using very cheap and very efficient models through that, because the reasoning is taking place, again, not in the model, but in that context layer.
Cool. I hope it answers the question by George. If not, then please unmute yourself as well. That's fine. Thank you. Max. Do we have any other questions? No? Can wait for one more minute. Let's enjoy the silence. That's fine. I think we're good.
I think we can proceed. Then Nick would take the second stage.
Yeah, great. Great, Max. Really enjoyed that presentation. So what I'm going to do is kind of just show a practical example of some of the stuff Max was talking about. And then feel free to ask questions or like interrupt me at any time, but I'm going to share my screen here. And yeah, just let me know if you guys can all see that. I think we're good. Hide this. Cool. So a lot of the points that Max was making are like, kind of abstract, and just to actually visually see like how are we grounding agent responses, and how are we making sure these LLMs are not, either hallucinating or just like coming up with a plan with incomplete information. And I'm going to do that through our interface here, which is what we built at CloudGo. But really this applies to any kind of AI tool that you're building, whether there's people here that are AI engineers, or if you're cloud engineers and, maybe your company is going to come to you with AI tooling, especially over the next 6 months to the next year, I think you're definitely going to see a lot more AI tooling in this space. And so just being aware of like how this stuff works and then being able to work with it is going to be really important moving forward. So this example is just from our application, and I'm going through like a migration approach from some like on-prem stuff to Azure. So I think like what we mentioned before is a lot of it is gathering that initial set of context. And so that's kind of how I start this conversation up here is, uploading all these different documents. And this is stuff that you would do when you're working with any kind of system, and connecting up, maybe my cloud credentials and my other integrations where all this disparate data is, and combining it into a complete picture so that the agent like understands what's actually going on. So that's how I always start these kinds of conversations, is doing that current state assessment of the cloud. And this is how you would probably prompt any agent. You can see here, then it like kind of overviews everything that's going on, all of the different pieces of services that we have, maybe across different systems or different clouds, and just gets like a holistic picture of that. Where things get a little bit more interesting is when you then have a goal in mind. So taking all its understanding of what your cloud is and trying to recommend a new like move, whether it's a migration or a modernization or anything like that. That's really where the context layer becomes important for like the knowledge side of things, understanding of actual cloud environments and like the best practices around that. And so you can see here, we spent a lot more time, this agent spent a lot more time thinking about this particular problem rather than just like overviewing what currently happened. And if we open up the thinking steps here, when I ask for a migration approach, we see it actually lists out like the knowledge graph files that were analyzed. So this is our way of building a knowledge layer. There's many ways of doing this, but the way we have it work is that the agent can query our knowledge base multiple times with different ideas that it has for how to go about doing this migration. And it's using all that context it gathered in the step before that to make these kind of queries. Then what happens is it'll go to like our data layer, whether you're using vector stores or knowledge graphs or whatever, it'll touch like over 1,000 nodes or points, and those nodes will get filtered and like re-ranked to optimize for the specific task at hand. So grabbing not only like whatever is the most important for the task that you're doing, in this case it's an Azure migration, but then also grabbing some additional files which the agent may not have thought of at the time, but are actually really relevant to what we're doing. And that kind of takes some of the like parts out of the LLM and puts it into the retrieval system so that the LLM doesn't need to be like thinking through each of those individual queries as much. So then once all that's together, then it gets like a solid set of files that it can overview. In this case, it was 47. And from there, it can choose like what it wants to pull from and what it's going to actually end up citing as its sources of truth in your final output. So we can see what that kind of looks like here in this migration readiness assessment here, where it's going to like overview kind of like what I'm actually going to do and other related information. The coolest thing here I want to point out is that, you know, you can see here in this bolded sentence, it's actually decided that we're not ready to migrate yet because it doesn't have enough information about some of the other stuff that Max is talking about, like the operational side of the business and like the business context. So where a traditional LLM might just like give you a plan and say like, you know, do your best with this. When you ground a system in this knowledge layer and you make sure that each of its recommendations has a direct source of truth that it came from, you can prevent it from just having to like make up a plan with incomplete information. And so I get flagged here that like, this is, you know, this is my best approach with the current information and like an overview, but I'm not ready for a detailed plan unless like we get more context. And so I purposely set up the chat to do this. So then I can go ahead and upload more information. This is where you connect up your company documentation. And now it should have enough because it has more information about our dependencies and like what our actual requirements for this migration are going to be. And then we can go ahead and build like an actual target state migration approach. So this like knowledge layer is important to not just like represent the infrastructure and services, but also like the dependencies between things and how all of these different services connect together. So you can see here, like each of the recommendations that we get has like an actual source documentation that it came from. And then when we're suggesting things to do in Azure, for example, we link the documentation right there in line. So for each recommendation, you can see where this came from. And like, this is where that traceability comes in that Max was mentioning. The human reviewer can go in and identify for any individual topic that the agent was thinking about where that came from and like what's the source of truth of that. So like here, for example, if I'm designing the firewall, I can go ahead and like click on the Azure Firewall Design Guidance documentation, and it should map up to what the agent was talking about when it's designing the firewall. Some cool stuff here for any like cloud engineers, like we can build, you know, architecture diagrams. You know, these agents are getting really good at doing this kind of stuff, and like landing zone recommendations, all this kind of stuff that you would want to do in your initial set of research as a cloud engineer. Let's go through this though. Oh yeah, did someone have a question there?
I do have a quick one.
Yeah, yeah, I can't see the mate, so.
Yeah, so when we have usually in corporate, right, we do have multiple in Azure, multiple subscription, and AWS it's organization, right? And you have a central hub and spoke model most of the time for your networking. So when we are doing migration for one of the accounts and the resources over there, how do we provide the other information? Because it's almost hidden most of the time. It's with infrastructure team. And what are the ways you recommend and how we deal with that situation here?
Yeah, so when oftentimes in AWS, you'll have like the overall organization, which then has like the sub organizations within it. And as long as you're connecting up the credentials for that like overarching one, which can read all the other ones, then we can assume roles in those individual like organizations and then like combine all the context together. If that's not the case though, even like you have multiple different cloud providers, you can connect up multiple sources at once in a chat, and then it can just like individually go through all those and then combine them all together. That might look like, you know, connecting up multiple credentials over here or whatever AI system you're using. And then maybe you might need to do multiple chats in a row saying like, okay, here's what we have going on over here. Here's like how this system works, and just step through one by one in more of a conversational flow before you're ready to jump into like the actual migration plan. that's where it's like useful to have this kind of chat interface where you can not just like try to one-shot everything. You can kind of work your way through all the different pieces before you get to like the actual plan.
Yeah, that makes sense. I was also wondering, right? For example, in cloud applications, usually the firewall, you mentioned firewall right now, right? So firewall that we have is not for infra, it's for the application, which is inside the infra, right?
Yep.
So the application will have archaic or RFCs. There are multiple terminologies that's there inside. So do you also take in the networking decision records and other stuff as an input for making decisions? How do you rectify what is needed over there? Because it's a hidden layer. You cannot see it from code or from the infrastructure. So
right. Yeah, that's where like application layer context is super important. And this obviously depends on like whatever task you're doing is going to change like what context you want to bring in. So for our tool, like that would just mean, providing as much context for the application layer as you can. And that might be in the heads of people that need to be written down, or might be in some like documentation files or something. And providing that as additional context is going to help like ground these infrastructure decisions in how the application actually works. But anyone designing their own tools, what you'd want to do is just make sure that you design that system with that in mind. So don't like assume that just the cloud infrastructure alone is going to be able to like design your firewall. You want to like have an understanding of the application dependency there. And that goes for way more things than just like firewalls, but really anything like cloud infrastructure related is going to need a little bit of context into your application and how it actually works.
Yep, great, thanks.
Yeah. Yeah, and then just I can kind of finish off pretty quick here, but what kind of happens when you get this business context or application context or anything kind of surrounding the cloud that isn't exactly in the cloud? Well, what that expands and allows you to do is more things on the operational side. So not just like, what should we do? Like, what cloud should I move to? Or like, how should I spin this up? But how do I do that in like a safe way that makes sense for how like my company operates? Doing a migration for a 3-person team is going to be way different than doing it if you had a 20-person team. So here, like I'm just using that as an example to go through like a sequencing plan and stage this out into like 7 different waves. And this is something that is only going to be able to be done when you have that context into how long of a like time frame you have, or additional context about who the owners are and who the people actually executing this plan are going to be. And other stuff cool. That's cool too, like planning rollback strategies or disaster recovery. This is stuff that kind of needs that additional business context as well. And now that you connect that up, it allows you to do interesting things like any type of migration plan and control. Even like if there's any service providers or people working in the service provider industry here, stuff like customer ready deliverables and statements of work can be done in a system like this, because it doesn't just like know the cloud, it also knows like, what does this mean for the business? What, like, how much money are we saving, or what is actually being accomplished by this migration of plan? And then like lastly, like the level of detail you can get when you ground these agents in actual recommendations is that, and then adding in that business context, is you can get really granular on like individual tasks. So here in like kind of a product manager approach, I can break down not just like what to do and how to do it, but who should be doing it. So I can break up the master like plan in terms of like, weeks and milestones, but then I can get much more fine grained and like outline individual tasks and like who should be executing that task. And you can imagine trying to ask ChatGPT to do this. It doesn't know who the MSP program manager is. It doesn't know that you have that in your org. It doesn't know anything about like how your org actually operates. And so when you add that in as a final layer, you can get cool stuff like this, where you can get as fine grained as like each individual isolated task that is like required to complete this wave or this part of the migration. And so what I think like I kind of want to take away from this here is that for both like cloud engineers, or if there's any people interested in AI, like these types of tools are coming. And whether you're using a tool like ours, or you're trying to build your own, or you're trying to work with a new tool that your organization adopts, keeping an eye out for things like this, like when the agent recommends that it needs more context, that's like a good sign that it's trying to ground sources in reality. When it's able to get granular like this, that means it has like the right context. And then doing that human review as you're walking through this is still really important. You don't want to just like accept whatever the agent outputs. You want to be able to look back through the traceability that should be in tools like this, or any observability, and like understand why an agent made a recommendation and like what was the source or the reason behind that. I think this chat does a good job of that, and I think that's like the most important thing going forward. So that's really all I have. But if there's any questions about CloudGo specifically, how it works, or like what is actually going on in this chat, like feel free to ask. And then I can't see questions or anything because I'm still on this page, but just let me know.
No, I don't see any questions as well. So, hey everyone, do we have any questions from audience for Nick or Max? Please raise your hand, put your questions in the chat. Everything is okay for us. For me, I don't have any questions personally. It was very clear. Yeah.
All right, I will jump back over here.
Cool. So I think we are at the end of the call. If we don't have any questions, we can hang around for a minute and then leave. I will send the feedback form to everyone. Please fill it out and let us know what you want to see next, or what more. If you want to see more context from what CloudGo is providing, reach out to their site, CloudGo.ai, or reach out to Nick and Max on LinkedIn as well. They're available, and or you can reach out to our community and we can arrange something for you. Feel free to leave and or stay in the call if you have any questions, or take an early 15 minutes off from the call. We have some thank yous, by the way, Nick.
Yeah.
So.
Thank you, Eddie, KH, and Kostas. Yeah, everyone, feel free. Thank you for sticking with us for the presentation, the demo. If anyone's willing to stick around, we always love hearing if people have tried this out before, whether it's building a knowledge graph, vector database, or just been like, hey, I'm trying to do cloud stuff with just Claude or OpenAI models, and here's how my experience with context and like A/B testing, prompting, and whatnot. So if anyone has like a story of that, we always love to hear use cases, because we always talk to especially MSPs, consultants that have been trying to do some of this like pre-sales delivery processes with like getting Claude to really mimic how I hand off a one-pager or deliverable to a client, and that process. So we love hearing about it. But if just a thought.
Awesome.
I mean, for me, I'm still new to these topics, and I would just have to take my time to go through the website. And also, if I have any question, I would also like reach out to you, Max and Nick.
Of course.
I mean, also, does the website have like a tutorial kind of page where it walks you through like what's been done or what you can do?
Yeah, we have a resource page section where if you go to the website, we have case studies, examples of us working with different customers, use cases of CloudGo. We do have a free trial as well you get from our website, or you get a free trial straight from the DevOps World website as well. There's a special offer that we've just had long running on there. So there's a bunch of really low ways to kind of see what the CloudGo platform can do.
So okay, I mean, and I think I have a question now. So my question is, in a simple way or in the simple words, what can you tell me CloudGo offers, or what do you do? Doesn't just like, if I'm to like explain to a layman or to someone who is not techie oriented, what is CloudGo? What does CloudGo.ai does? What's their business vision, and what do you do?
Yeah, CloudGo is very basically just cloud intelligence simplified. If you don't have to really worry about what you know and what you don't know and how you communicate that to the system. CloudGo helps you get more value over the AI tools that either you want to use or that you're already using. And so that's what really the benefit of an organization, either bringing in something like a CloudGo or just the topic of our presentation, bringing in a context layer as the in-between between an AI model and your team.
Yeah, thank you very much.
Cool. Awesome, guys. And then we can depart and meet again next time. And it was really awesome. Thank you so much for your time, Max and Nick. We will love to hope you again in future and again and again. First of all, thank you for everyone who has attended our DevOps Wall meetup today. We will post it in YouTube channel that we have, and we will summarize it and try to put in an article from CloudGo side. And yeah,
Great.
let's
Yeah, thank you so much.
let's catch up
Same,
for
yeah,
the
yeah,
next
thank you.
time.
Yep. Thank you, Vishwas. Thank you, Amika. Thanks for hosting.